going to standby because they already see each other, then they are negotiating the rules. So if you can check, it's already able to ping, okay? That's why they're already able to negotiate, okay? So let's check the port channel first. Okay, as you can see here, it's no longer suspended. Okay, as long as P not down, P doesn't say up here but bundle. P is good. And then the bundle is now good. Interface trunk good. And then let's check again the standby brief. Okay, now we can see very good here. So it says, let's go back first here. Okay. So and this is core 1 standby brief. Okay, now you see it's active. Priority is 150. That's why it's active. For this VLAN 10, active is local. This one is saying that standby is this IP, which is core 2, right? So this is core 2, and their virtual IP address is this one, which is the virtual IP. Let's same here. It says priority is 100, state is standby. The active box is this one, which is core 1. The standby is local, which is this one. And the virtual IP is this one. Okay. Now we have the working default gateway, priority, standby. Let's go to here, access switch, and configure these ports for trunks. And then we'll do the same. We'll put the BTY domain, BTP domain on the spanning tree mode. All of them should match the spanning tree mode for consistency, and we'll not have spanning tree problems later. Okay, let's do that on the access switch. Okay, this is the access switch. Okay, so this is the access switch interface status. Okay, this one is going to core 1. This one's going to core 2. This one going to the PC. Okay, later we will test ping connectivity. Okay, so first thing is we'll do the VTP domain, just like core 1 and core 2. Okay, just the main name should be the same. BTP version 2 the same, BTP pruning, BTP mode is transparent. Alright, so okay, and then next is spanning tree mode, rapid per VLAN spanning tree. Okay, so let's go directly to the interface gigabit 0/0, or we can configure together because they are the same. Connect to core 1 and core 2. Okay, switch port, trunk in cancellation, that one queue, switch port mode, trunk. Okay, so show interface status. Okay, you can see here both interfaces are in trunk mode. Okay, show interface trunk. Okay, alright. Okay, so here we don't have a VLAN, we need to create also, because this is in transparent mode, remember. So we need to manually create VLAN. So VLAN 10, name HQ, users, VLAN 99, name MGM table management, and VLAN 999, name is native. Okay, so show VLAN brief. Okay, here we have already the BTP, we have the spanning tree, we have the VLANs, 10, 99, and for the native. Okay, so let's go back to the trunks. Interface range, where is it? This one and this one. Okay, switch port, trunk, native, VLAN 999. Okay, machine down. Okay, so show interface trunk, our native VLAN is 999. Okay, so so let's save this. Okay, now okay, so this one already configured for trunk, this one also. But here on the core 1 going down, and also this gigabit 0/2, we still need to put in trunk. Okay, let's do that. Let's do that. Okay, so here gigabit 0/2. Check again, status. Okay, so interface, this one, going to the access switch. Okay, switch port trunk encapsulation. We know this one already. Switch port mode trunk. Switch port trunk native VLAN 999 shot. Okay, verify show interface trunk. Okay, so okay, so as you can see, gigabit 02 is already trunking going down. Okay, okay, portion is okay. So okay, let's save that one. Okay, so let's do in core 2 as well. Show interface status. Okay, wait. Okay, show interface status. Checking. Okay, now it's also in trunk. Okay. Okay. Here in trunk. Why? Sorry. Let's check configuration why it's trunking. Oh, why? Because the other side is trunking. Okay. Anyway, let's configure it. Switch port trunk. Income solution. .1Q. Switch port mode. Trunk. Switch port trunk. Native VLAN 999. Shutdown. Okay, show interface status trunk, show interface trunk. Okay, so now it's trunking. Okay, let's save from time to time. Okay, so okay, let's go back here. So this one is trunking, this one is trunking. Okay, let's check spanning tree. Okay, here let's check spanning tree for VLAN 10. Okay, spanning tree for VLAN 10. Okay, something wrong is here. Something wrong here. It's saying this breaches the root. All right, so let's troubleshoot. Okay, so let's troubleshoot. What happens is ACC1 switch becomes the root bridge of VLAN 1 for some reason. Okay, so spanning tree root bridge election happen in the background, and I'll explain later why it chooses this one. There are several details that they go through to select the root bridge for VLAN 10, and somehow the access switch ended up being the root bridge. Okay, there are several ways to troubleshoot this one, and okay, for the because we are demoing the spanning tree root for core 1 and core 2. Okay, although there are several ways to check why this becomes the root bridge from the election, because both three switches, both three core 1, core 2, and ACCI's access switch, they are on their default settings, so we didn't set anything. So that's why they have their I'll explain later, maybe later in another video episode, but for now we will fix this so that core 1 will be the root primary, core 2 will be secondary, and this one is way below the spanning tree, just a member of the spanning tree. Okay, so this one is manual style config, meaning manually set priority on core 1 and set priority on secondary priority on core 2. Okay, so this is the command config. Okay, for now, as I said, I'll explain later why it was chosen, but for now, let's fix this for the demo purpose. Let's fix this in this way. Let's set core 1 as the spanning root for the spanning tree. Okay, since we are setting spanning tree priorities, let's follow now as early now our convention that if odd numbered VLANs, let's put priority on core 1 and even number VLANs on core 2. Okay, so since VLAN 10 is an even number, let's put the core 2 as the primary root bridge for VLAN 10. Okay, so spanning tree, VLAN 10, priority, sorry, spanning tree VLAN 10. Priority is, okay, this is some numbers. We'll use the lowest one, 4096. Alright, okay. And then, we'll use the same command. This one is in increment of 4096. So the next one will be 811. 4096 times 2. Okay, so here, so what this means is core 2 will be the primary root bridge or the root bridge for VLAN 10 because we set it manually to be. Okay, so if we check, show spanning tree for VLAN 10, now it becomes that this bridge is the root. So if we check on the here, which is the previous one, if we check again, it's no longer the it's no longer the root bridge. Okay, so this is core 2 is the primary or the root bridge because VLAN 10 is an even numbered VLAN and core 2 it goes to core 2 for even numbered VLANs. Okay, so let's configure core 1 as the secondary root bridge. Spanning tree VLAN 10. Priority is okay, so 4096 times 2 or the next one plus 4096 8192. Okay, 8192. Okay, so if you check spanning tree VLAN 10. Okay, so it says here that the root bridge is in port channel 1 which is going to core 2 because core 2 is the root of this, so it's correct. So okay, so it's the root bridge is in core 2. That's what it's saying. Okay, that's 1496 but plus 10, that's why it's 4106. Yeah, because VLAN number is added here, so 8192 plus 10 here. So okay, so we have set core 2 as a root bridge for VLAN 10 and then core 1 is the backup root bridge if core 2 fails. Okay, so if we check here, choose spanning tree for VLAN 10. Okay, so if you notice the uplinks, the two uplinks of this access switch. Okay, here gigabit 01 is saying alternate and block. Okay, but the gigabit 01 is root forwarding. Okay, so if we check gigabit 01 here is forwarding and gigabit 00 is block. So which is correct because the root of the spanning tree is core 2. So his traffic should be good here, not here, because this is just the backup. So not here. The traffic will go from here to here because this is the root of the spanning tree and it will go back like this. So this one will not be used because it's in blocking. Here is forwarding on this side, forwarding, but on this side is blocking. Okay, so let's go back. Okay, so now it's already 1 hour. Okay, so now we will configure this one access port and put this IP so we can test. Check the ping the virtual IP. It's a virtual IP. Okay, so let's go to here. So show interface status. Okay, so If you check the drawing, so gigabit 1/0. Oh, sorry. We don't have 1/0. Oh, no. Here, this one is just in the drawing, but in actual, we can use the gigabit 0/2 for this demo. Because I need to shut down and start again. It will take some time.